Good day, viewers all over the world. We are still on the topic partial fractions. So in our last class, I gave this same example. We are to resolve this compound fraction into sum of its partial fraction. And I used the first method of resolution, which is called the cover-up method. You can check my video on that cover-up method. So today we want to apply the method of comparing coefficients to solve the same problem. We want to use to solve the same problem, and at the end of the day, we are going to get the same answer. So it now depends on what you want to, how you want to approach the approach you want to follow whenever you are resolving a compound fraction to sum of its partial fraction. Now let's go. There are two factors here, linear factors. That's why we express this as A all over the first one, then B all over the second one. You can use any letters. So in this case now, if I multiply everything through by the denominator of the left hand side, I'm going to get 7x. I'm going to get 7x plus 9. I will get 7x plus 19. I'm going to get 7x plus 19 to be equal to A into bracket. This will be x plus 5. Then plus B into bracket x plus 1. That's what I'm going to get. If I do that correctly, that is what I'm going to get. So from there, from this point now, that's where we apply cover-up method the other time. But under method of comparing coefficients, we are not going to use cover-up method. That is, we put x to be equal to something to get the value of the first unknown. Then we do put x to the value of to minus 1 to get the value of the second unknown. But in this case, we are going to open up. That is, we expand. We are going to expand. I'm going to have ax plus 5a plus bx plus 1. We now do the necessary arrangement because we want to compare coefficients. Yes, it is ax, this is bx. We can say this is a plus b into bracket x, then plus, these are constants, 5a plus 1. So everything is 7x plus 19. So at this point, we compare coefficients. If you look at this now, at the left-hand side, this is 7x. The coefficient of x is 7. We write it down. Is equal to, what's the coefficient of x at the right-hand side? A plus b. That is equation 1. We've decided to compare the first coefficient. Then let's look at this constant. This constant is 19. The constant is 19. The constant here is 19. Is equal to, let's look at the constant at the right hand side. It is 5a plus 1. This is equation 2. No, this is b. Here will be b because we use b to multiply. This is b, not 1. So 5a plus b. So these are from the method that we apply there and what we compare. We are able to get two equations with two variables as we have it on the board. There are two equations with two variables as we have it on the board. So we are going to solve equation 2, equation 1 and 2 simultaneously because this is simultaneous equation. Then we can say equation 2. From there now, we can say that equation 2 minus equation 1. If you do that, 19 minus 7 is 12 is equal to 5a minus a is 4a. Then b minus b is 0. Then we are going to continue from there. Divide both sides by 4. 4 will cancel 4. 4 here 1, 4 here 3. At the end of the day, we are able to get the value of a to be equal to 3. And that's what we have done. We are able to get the value of a to be equal to 3. We have been able to get the value of a to be equal to 3. That's what we have done. So this is a plus b. This is equation 1 and this is equation 2. We have been able to get the value of a to be equal to 3 in the first one. So this is 7. So since we have got the value of a, we just come back and say substitute a is equal to 3 into equation 1. And if we do that, we have 7 is equal to a is 3 plus b. Then 7 minus 3 is equal to b. So if you continue from there, b is equal to 4. So we have been able to get the value of a to be equal to 3 and b to be equal to 4. So finally, the sum of its partial fraction will now be a 3 all over x plus 1, then plus 4 all over x plus 5, which is the same value that we got when we apply cover-up method. So under the method of resolution, it depends on what you want to use. Once you look at the question, once you resolve everything to a straight line, you are the one that will look at the question and just choose the one that you are comfortable with. Either you want to use cover-up method or method of comparing coefficients. At the end of the day, you are still going to get the same value. And that is what we should note. Thank you.